Lots and lots of water testing about the quality of water in our little Namaquah Creek here and the Rock River and around Rock Island. And so I'm going to turn it over to Dr. Kevin Geedey from Augustana College and his trusty assistant to explain what's with our water.
This project would have never happened without the leadership of CORE and our Upper Mississippi Center, which is part of Augustana College. The Upper Mississippi Center connects faculty and students with people in the community that can use our expertise. And so this project came about through the action of CORE and is part of what CORE calls its Sustainable Working Landscape Initiative. So many faculty have been involved in this, and many more students from geology, students from geography, environmental studies students, and biology students as well. So I'm presenting a lot of people's data here, certainly not just mine. So what we want to do today, Ryan and I would like to tell you a little bit about why the Rock Island watershed matters, and what do we know about water quality in this watershed. Then third, we'll talk about how the streams are functioning as ecosystems. Are they healthy? And then last, we'll talk a little bit about what we can do, one of the things we can do to improve in the Blackhawk site. All right, so this is a view that shouldn't be unfamiliar to you. This is where the Rock River comes into the Mississippi. And so water quality in the Midwest, of course, is important as it all ends up in the Mississippi River. Our watershed that we studied for the past several years is outlined in yellow there. It's a relatively small watershed, but it's the largest single watershed in Rock Island. So we just refer to it as the Rock Island watershed, even though, of course, there's multiple watersheds in Rock Island. So it starts...
Explain what a watershed is, what that means.
Sure. So a watershed is just an area of the landscape that the water drains down to a single point. So all the rain that falls and drains off into the little streams running behind people's houses, etc., rain in this area all ends up down here in Blackhawk Park. Right, so we looked at this particular watershed at the request of Rock Island. So you may think the little streams that run in the ravines around here aren't that important and don't have a big impact, but they add up. They're small, but they're numerous, and they can have real impact. So this is a satellite image of the dead zone in the Gulf of Mexico. So the dead zone is an area of chronically low oxygen concentrations, where there's not very much oxygen in the water. Aquatic organisms need oxygen to survive, right? So low oxygen is a real health problem for them. And when the oxygen drops low enough, the fish will die, shellfish will die, and it affects people's livelihoods as well that rely on the Gulf. Lots of research has gone into this, and scientists say the primary source of this dead zone is the Midwest, right? It's us. It's nutrients, things like nitrogen and phosphorus running off in our streams and running into the Mississippi River, and eventually causing water quality problems in the Gulf of Mexico. Right, so nutrients sound like a good thing. Every living thing needs nitrogen and phosphorus to survive, but this is a case where you can definitely have too much of a good thing. Right? You can definitely have too much of a good thing. Too much nitrogen and too much phosphorus cause excessive algae growth, too much algae growth, and then when all that algae dies and decomposes, the bacteria that consume it use up the oxygen. You end up with not enough oxygen left for the other parts of the ecosystem, right? So what we do in Illinois matters, right? How we treat the little streams that run behind our houses and in the urban streams that run through the city, turns out it matters. All right, so here is an expanded view of the watershed that we studied for the past few years. So you can see Hy-Vee up there at top. The watershed has its border right next to Rock Island High School. And of course, here we have Blackhawk Park down in the lower part of the watershed. So all of the streams in this area come together and end up flowing into the Rock River right here in the park. We broke up the watershed into smaller pieces. And we broke it up into smaller pieces to study it more carefully. So this map shows where all our sampling sites were, many of them in people's backyards. They very kindly gave us permission to hike through their backyards at random intervals and hike into their ravines. And we tried to choose these strategically to break out different pieces of the watershed, right? So this sample site here picks up all of the streams that were running there, right? We picked up different regions of the city to try to get a picture of what's going on over the whole city. Now, of interest to us here tonight, there were 3 sites actually in Black Hawk Park. One of those sites is that the actual confluence, the actual spot where the whole stream network is draining into the Rock River. I'm not going to talk very much about that site tonight because frankly we had some technical problems sampling it. Sometimes the water was flowing from this watershed out into the Rock River. Other times when the Rock River was high, the water was flowing from the Rock River back into the site. And so sometimes we were sure we were getting runoff from the watershed, which is what we wanted. Other times we thought we were just getting Rock River water. So I'm not going to say too much about that site. We have 2 sites that were in the park proper. One site, which we called Site 9, is a little stream that runs right along John Deere Road, just sort of right below the road and that steep, beyond that steep embankment. The other site is a little bit of a hike into the woods, about a 15-minute hike out past the nature trail that is behind Singing Bird. Right, so those are the 2 sites we're going to talk more about tonight. So this is Site 9, which we'll refer to as the John Deere site. So you just go right down the road, and this is the little bridge that crosses it off in the distance. And here Ryan took a picture close up. The stream is not usually this muddy, but Ryan took a picture this week. So we've had a lot of rain and a lot of mud. And this is the site we're going to refer to as the Singing Bird site. It's a good walk off into the woods. And here's the bridge crossing where we sampled, and there's a view of that site as well. Okay, we have tons of data on the watershed. There's no way we can tell you about all of it tonight. So we're going to try and hit some of the highlights that we thought, that Ryan and I thought you would be most interested in. So we're going to talk about some pollutants. Pollutants that are associated with sewage and fertilizer, like phosphate and nitrate, the things that are behind that dead zone in the Gulf of Mexico. But we're also going to tell you about some other pollutants, like chloride, lead, and mercury. Then Ryan's going to tell you about the health of these streams. We're going to look at the invertebrates that live in the streams. We're also going to look at nutrient uptake. Healthy streams should not treat things like nitrate and phosphate like a sewer line. Right? A sewer line just transports stuff from one place to another. A healthy stream is a living ecosystem, and so should use that material. So by measuring nutrient uptake, we're measuring the rate at which a healthy stream is actually able to absorb and retain stuff like phosphorus and stuff like nitrogen. So Ryan's going to tell you a little bit about that. We also looked at leaf decomposition as a way of looking at the health of the streams. You might wonder, what happens to all the leaves when they fall in a stream? Well, healthy streams decompose them. There's animals that make their living shredding up those leaves, and then bacteria and fungus consume them further. So a healthy stream should not just transport leaves from one point to another, should also break them down. So we look at leaf decomposition rates as well. Finally, and Ryan will tell you a little bit about the metabolism of these streams. How much photosynthesis is going on by algae in the stream? How much respiration is going on by all the animals and bacteria and algae in the stream, which is another way to look at how the ecosystem is functioning. So those are the things we're going to talk about tonight. All right, so we're going to start with pollutants that are often associated with sewage and fertilizer. We're going to look at phosphate, and I want to tell you a little bit about how all of these graphs are formatted that we're going to look at tonight. So this is a box plot, and all of these graphs have all of the data from all the sites in Rock Island. Right? So you're looking at the variation in the entire watershed. This box in the middle represents the middle 50% of the data. Right? That's the middle 50% of the data. The vertical line in the middle represents the median, right? So the middle part of the data set. These whiskers on the left and right side of the graphs represent the lower 25% and the upper 25% of the observed data. So the box with its whiskers is all of the data. And then in each graph, we're going to show you where the John Deere road site was in this distribution and where the Singing Bird site was in this distribution. So we'll show you where the Black Hawk sites fell with respect to these variables. So ideally, we would like to see phosphate lower than 0.1 milligrams per liter. So you can see that all of the streams in Rock Island are well above that. Right? All of the streams in Rock Island that we measured are pretty enriched in phosphorus. So that's not great news. The John Deere road site is in the lower end of our phosphate concentration. Singing Bird, unfortunately, is in the higher end of our phosphorus concentrations. Phosphorus doesn't always represent sewage, though. Phosphorus does naturally occur in ecosystems, and it is associated with sediment. And so where you have a lot of erosion, you can also get a lot of phosphorus. And Singing Bird does have a little bit of an erosion problem. If you hike out to that stream, those stream banks are cut in by the water pretty good. And if you go out there after a storm, it's not uncommon to see the bank kind of slumped over into the stream. So Singing Bird may be picking up some phosphorus from there. Nitrate, here we have great news. This graph shows us that Singing Bird and John Deere are the two lowest nitrate streams in the entire Rock Island watershed. Right, that's pretty good news for us. They were the lowest, consistently the lowest nitrate streams in our data set. Just as a general measure of quality, we'd like to see nitrate lower than 1 milligram per liter, and we can see that the two streams in the park here that we studied are the only streams in Rock Island that meet that healthy criteria. So they're the great natural surroundings of forest and good land use. We have really good numbers here. Okay. So for things associated with sewage and fertilizer, the Black Hawk streams are fairly clean, right? Which makes sense. We don't have septic fields leaching in. We don't have sewer lines there in town. We don't have fertilizers being used in the park. I should mention that we did measure fecal coliform bacteria across the entire watershed, and which is not surprising for urban streams. We found fecal coliform bacteria everywhere. Right, in every site in the city has fecal coliform bacteria. I do need to mention, though, that the test we used shows us the presence of the bacteria, but it doesn't necessarily tell us the source of the bacteria. Right? All mammals produce fecal coliform bacteria when they poop. Right? So this could be in the streams in Black Hawk. This could be from deer. It could be from dogs. It could be from raccoons. Right? We don't know the source. It's not necessarily a sign of human sewage. All right. We're going to look at some other fairly serious pollutants across the watershed. So chlorine, right? Animals that live in fresh water, animals that have evolved living in fresh water, don't have much of an ability to deal with chlorine. Right? They're not like ocean animals that are in an area that has lots of sodium chloride or salt all the time. So freshwater animals are very limited in their ability to deal with salty water. Ideally, we would like to see chloride levels in milligrams of chloride per liter low, under 50 for sure. We see that Singing Bird is the cleanest site in the entire Rock Island watershed with respect to chloride. Right, great. Right, no evidence of road salt runoff back at the Singing Bird Lodge site, nothing to indicate excessive levels of chlorine. Not as good a picture for the John Deere road site. It's in the lower half of the data, but I do have to tell you this is the average, and we've seen spikes at the John Deere site as high as 700 milligrams per liter, and that's much higher than you would need to begin to damage aquatic invertebrates. Aquatic invertebrates start to be damaged at around 300 milligrams per liter. And if our John Deere site hits 700 from time to time, that really could be doing some damage to some of the animals that live there. Why is John Deere Road higher? We don't know for sure, but I don't think it's a coincidence that it's up by the road. Right? The site is right up by John Deere Road and probably gets significant road salt runoff. All right, we're going to look briefly at lead and mercury. And here we see a very similar pattern for both of these variables. Right? Lead and mercury are both dangerous. We want them as low as possible in the environment. We see in both cases the singing bird site is on the lower end of what we see across Rock Islands. Again, the singing bird site is one of the cleaner sites in the city. John Deere Road, unfortunately, the John Deere site is up on the high end, and for lead, it's one of the higher streams in the entire Rock Island watershed. Again, I don't think it's a coincidence that that's a site that's right by a very busy road. Okay, so if we're looking at the water quality overall, it's mixed. There's some good news and bad news. Singing Bird Site is among the cleanest in Rock Island for most of the water quality variables we measured. The John Deere Road is not nearly as good. Again, we hypothesized that this might be due to the direct impact of the road. Okay, we're going to transition now to start to talk about ecosystem health. So we know a little bit about the chemistry. Now we're going to learn about how these things interact to produce ecosystem health patterns in the watershed. And I'm very proud to have my student, Ryan Johnson, who's a junior at Augustana College. I've done research with him for 3 years. He's an excellent student, and I'm glad to have him help me with that part of the talk.
Okay. So I heard a lot from my colleague on the video over there about the water quality, but the next question is this actually impacting how the stream is working? Like, how is it impacting the organisms that live there? Is it impacting things that are supposed to be doing with a healthy stream? So given like the climate, biological communities, hydrologies of certain areas of the country, we may expect to see certain like rates of certain things happening. So for example,
Ryan, if you talk a little louder.
all right, can everyone hear me now? Okay, cool. So what I was saying was that given like the climate, biological communities, and like hydrology of the area, they were trying to say these certain rates may have certain like what we call it background rates. So that's like what we like would expect to see in the stream if it's not impaired at all. So for example, when we look at leaf decomposition, which we'll look at in a little bit. If you like are thinking about areas around here, we have like a lot of deciduous trees. But if you think about like the Southwest, they would have a leaf decomposition rate that's normally very low because there's not many leaves around there, and so the communities are adapted to those conditions over time. And so if we know like the background rate of like some of these things, we can kind of see if it's impaired or not. And also these functions or how the stream is working is controlled by many factors. So some things that may be high and we may consider pollutants may increase the rates of some things that we may consider to be more healthy. And I'll give the example later. So basically we're linking the water quality data to how the stream is working. Okay, so for the first thing that we looked at was macroinvertebrates. So these are basically insects that are flying around normally, but a part of their life cycle they spend in the water. As like larvae, and they grow up to become the adult stage. And if you have time afterwards, we brought some of the macroinvertebrates that we do find in Rock Island right in front of the computer there in little vials, so take a look at those, they're pretty cool. So what we're looking here is this thing called Family Biotic Index. So what this looks at is all the organisms that we collect from these streams, they have different tolerances to pollution. So things that have, and each family that we categorize has a certain number associated with it. So a high number means that the organism is very pollution tolerant, while a lower number means that the organism is more pollution intolerant. And so if we want to look for a healthy stream, we should try to go for a lower number if possible. So what we see in this box plot is after you explain how it works. We see the John Deere Road site is in the upper 25% on a higher family biotic index, and what this means is there's more pollution tolerant organisms that live in there versus pollution intolerant organisms. And so this organism in particular is a bloodworm. It's actually the larva stage. It's not actually a worm, it's actually the larva stage of little midges or like those like gnats and things that like fly around your face and annoy you all the time. And then the other one is the caddisfly larva. They're pretty cool. They kind of build webs like spiders do, but instead of catching insects, I mean some of them do catch insects, but most of them catch like sediment and they eat all that organic matter that they catch from that. But we see a lower number for the singing bird site, indicating that any of the water quality that's happening seems to be reflected in how it's represented in the organisms that are there, as there's more pollution intolerant organisms there. Okay, so the next parameter is nutrient uptake. So I'm sure many of you in your garden a lot, and so some of the things that you have to do is you have to put nutrients into the soil that these plants take up. And we're measuring the rate at which those nutrients are being taken up by plants in the stream or algae, microscopic algae. And we measure specifically nitrogen uptake. And what we see, we didn't do the singing bird site, but in the John Deere site, we see that it's like in the middle of 50%, which is good news. It means that the stream is still functioning, it's still taking up nutrients. If it wasn't functioning correctly, it would be like more of like a gutter where the nutrients just go straight through and don't be taken and are not taken up at all. So that's some good news. All right. All right. So leaf decomposition. So for this study, basically what we did was we got leaves in the fall, we put them in bags, we put them in the streams, and we measured the mass before and after to get like basically mass loss per day of two different types of maple and oak leaves. So we can see in the maple leaves that the two sites are kind of in the middle of 50%, which is good news. It means that the stream is still functioning even with the impairment that might be there, and decomposing leaves. And it's really cool because every single fall, or really all the time, nature has a really large challenge of trying to decompose all these leaves. And if they were not decomposed, we would be in piles and piles of decomposed matter not being, or just dead matter just not being decomposed. So it's doing its job and it's decomposing them. And then for oak leaves, they are in the upper 50%, which is really good. And it's kind of interesting to think about, because the park does have like a lot of oak trees around, like legacy oaks and things. So it's interesting to see that those rates are higher. It could mean that the assemblage of vertebrates and things like that to decompose them are much higher, or at the background rate that you would expect for this area. Okay. So one other thing that we did with this study was that we compared the functioning with certain like parameters. So this one parameter is impervious surfaces. What we mean by impervious is just that the water hits the surface and does not go through. It just runs right off of it. It's impermeable. And so a high percentage of this is not really good. It means the area is like more urban, and it could mean that the stream is like has really fast fluctuations in water, which is not good for the organisms that live in there. But what we see is that with higher impervious surface, we see a lower amount of leaf decomposition, and they're relatively good correlate. There's really still a good correlation for an ecological study. What's interesting is that the quote-unquote more healthier site of singing bird, they're on the higher end of this, which means that which is good because it means that keeping the impervious surface out of that part of the park is actually benefiting the working of the stream. Which is good news. Okay, next slide. All right, the last thing that we're looking at is stream metabolism. And whether these certain parameters are high or low, can't really tell us if it's necessarily healthy or not, but it does give indication of like what the overall biological activity in the stream is doing. So photosynthesizers are photosynthesizers. They give off oxygen, while things that breathe like we do, we give off CO2. And so what we see is that the rate of photosynthesis in the park in the singing bird side is very, very low. But the respiration is much higher. You can see on the scale there, 5,000 versus like to like 100, like or 190, like in the same distance. So, but this is to be expected for the stream because of all the shade that's around it, and closes the canopy and can limit our algae growth. So that's a good sign that we're seeing what we would expect for a site like this. Next slide, please. So the main takeaway points here is that despite having some impairment at the John Deere Road site, it appears that the streams are still functioning. Now, if it's like, the question of whether it might be like at a threshold point where like, if there's any more impairment, it may just completely crash that function. We don't really have the answers to that, but there's good that they are still functioning despite this impairment. And like I said, near the John Deere Road site, there is, because of the higher chloride, higher trace metals, higher phosphate could be impacting the biological community that's there, and so some of these parameters are much lower than we would expect for this area. Okay, so we have an idea now, like where the problems may be. So how do we go about solving this? So the first thing that we need to do is we need to do some more studies to try to source where some of these problems are coming from. So like for example, we think that the chloride may be coming from road salt, but we're not 100% sure it is. We don't really know where the lead is coming from exactly. It could be from like a lead pipe and just leaking out of that. So that's the first step. And if it is coming from the road or these pipes, there's a few things that we could do. You could try to bring in construction equipment and try to create a barrier between the road and stream, usually like with an impermeable material like clay, which water cannot go through, which should keep the pollutants away from the stream. The other thing that we can do is try to bioremediate the site. So there's these certain plants out there called hyperaccumulators. They can basically take up like a lot of these trace metals, or heavy metals and chloride and things like that other plants can't. And so if you plant them in between the road and the stream, they could be uptaking a lot of these things. They may be impairing the stream quite effectively. And one example of this is a good hyperaccumulator for chloride is any trees in the willow tree family, basically. And then the more harder change is kind of like a broader social change. So we need to have, or basically there needs to be some social change that happens that kind of fix it, or that kind of shifts the norms and what the values and beliefs that people have towards these streams being more positive and being more important, and then infrastructure that may be damaged and may be impaired these streams can be fixed to help fix that problem. It's kind of like fixing the root of the problem, which is the ultimate goal. But there is some other quicker fixes that can happen if you have some money. So, okay. And with that, I would like to thank CORE, the Upper Mississippi Center, the Sustainable Working Landscapes Initiative, my great colleague and mentor, Dr. Geedey, Dr. Michael Reiser, who couldn't be here, but he's the director of the Upper Mississippi Center, and many of the great students with bright minds that did many of these studies over many years to get all this data. So thank you for listening, and we're ready to take questions. Yeah.
Yeah, I'd seen or you had a low chloride metal with a high phosphate metal.
Right.
You think they might go hand in hand? Maybe people walk pets and maybe people have pet waste. How do you explain it?
Please repeat the question.
The question is, we've got at Singing Bird low chloride but high phosphate. We might think those things would go hand in hand, so what do we think might explain it? We often see those variables go hand in hand because they're both associated with human activities, like road salt, sewage leaking, fertilizer, etc. I don't, my belief is that's not what's happening at Singing Bird. I think a lot of what's going on at Singing Bird for phosphorus may be erosion based. That those banks are really getting dug in by the stream pretty fast, and that the soil's releasing more phosphorus there than we might expect otherwise. The bank stability there is a little bit lower than we might like to see. I don't think there's a direct sewage leak or anything like that there.
Another question.
Oh.
How do you establish a control? What is the optimum level of some of these streams? Do you have any data, for instance, well, you probably don't have any data from pre-settlement times. Do you have any streams that maybe are relatively like that?
Sure. We didn't have completely forested reference streams in this study, but as I was going through the graphs, I talked a little bit about sort of target ranges for what's regarded as healthy, and that's based on larger surveys of other streams, including streams that don't have a lot of development in them.
We live right up the hill, actually, and it seems like most of the houses around, including ourselves, have used fertilizer to make our grass. Do you feel that when we use that, does the grass take that and use it, or does much of it go, I'm only about 100 yards to their stream? Does it get down to that stream?
Unfortunately, I think the data suggests that.
Can we repeat the question? You can't hear the questions.
Say again?
Just repeat the question.
So what about yard fertilizer? Right? If you have your backyard that goes right up to the ravine and you have a stream down there, how much of the yard fertilizer, how much of the phosphorus and nitrogen you're putting in your yard actually ends up in the stream? It really depends a lot on weather and a lot on the state of the grass at the time, but there's been studies that show really a pretty significant portion can end up in the stream. And some of the backyards around here, I know because we've climbed in and out of them, have pretty steep slopes, and so it doesn't take a lot of rain to get stuff washing down that slope. And so I think that is a threat.
Are there any, besides road salt, are there any natural sources of chlorine?
Yeah, there are some mineral sources of chloride, but none of those could get the concentrations as high as what we're seeing in the streams. Road salt is probably the main culprit, although it is possible in some of the sites outside of the park. I know Rock Island is worried that you could have leaking drinking water lines leaking into the storm sewers, which then could empty into the streams. So actual chlorinated drinking water could be part of the issue there in Rock Island. Probably not in Singing Bird, right? But there could be some leaking drinking water lines there too.
You mentioned the higher levels of heavy metals and being related in proximity to the roadside. Could you be a little more detailed about that, where it comes from? And also, secondly, how does that relate to our water infrastructure?
So, could I give more detail about where the heavy metals might be coming from and how that's related to proximity to the road? Unfortunately, I can't give a lot more detail about that. Lead doesn't tend to go away, right? Once it's in the soil, it stays in the soil. And once an ecosystem is contaminated with lead, it tends not to move very far. As we were noticing the lead levels, the data was coming back from the lead levels in the streams, in some of the streams in Rock Island, we've been curious about what the source of that lead is, right? Lead-based paint hasn't been around for a while. People don't use it now. Lead in gasoline went out a long time ago, but yet once that lead gets in the soil, it stays. And I know one of the things that another Sustainable Working Landscape Initiative has been looking at lead in Davenport, Iowa, and the older houses, the lead is right there in the soil, especially in a tree lawn nearest the road. Right, that soil just has a lot of lead in it. And I suspect, although I cannot prove, that we're still probably looking at some legacy lead that's been there for a long time.
Also, it could be from like fossil fuels if they were burning coal back in the day here. Some of the fallout from that, particulate matter and stuff that gets in the air could like fall into these soils, and obviously this, like how Dr. Geedey said, they can stay in the area for a long time. As far as mercury, kind of like could be from fossil fuels too, again, like coal and things. And are there any other sources? Yeah, that's pretty much what it could be from. And it's also very similar to lead. It stays in the system for a long time. It doesn't get recycled very much. And that could possibly be why you see the high spikes. Yeah.
Yeah, you were talking about John Deere and Singing Bird sites. Can you give us kind of an overview of what the other sites, the Watershed, just some highlights?
Sure. Can you you go back to the watershed map? Yeah, I'd be happy to do that. Can you get an overview of the other sides of the health of the watershed? Yeah, this one or that one, either one's fine. Yep, either one. So one of the main patterns, when we started this research, one of the things that we were most interested to see is one of the really cool parts about Rock Island is all the ravines, right? So we have all these little islands of green space, these little ravines that bisect the neighborhoods. And we wondered whether or not those ravines were doing any ecological work. Were the streams cleaner as they go, they get cleaned up as they go through the ravines? And our data are not super conclusive there, but we do have a pattern of water quality overall. These highest altitude highland sites, the little smallest streams up in the upper reaches of the watershed, those tend to be the most polluted. And they're the most polluted in a way that's very consistent, unfortunately, with sewage. They have very low oxygen levels, they have high phosphorus, high ammonia, high nitrate, low pH, a whole cluster of traits that go together that say probably leaking sewage. All right, so there is some evidence of sewage contamination in the upper part of the watershed. As you go down the watershed, the streams tend to get cleaner with exceptions. Right, they tend to get a little cleaner with exceptions. So that's kind of the overall picture. So it does look like there might be some sewage infiltration in the watershed overall. I should say these upper sites here are also associated with the highest levels of fecal coliform bacteria. Right, there's fecal coliform in all of the streams in Rock Island, but the highest levels are in the upper parts of the watershed. And you see some of these streams that are perfectly straight lines. Those are mostly underground and are storm sewer pipes.
Did that have something to do with flow rates? I mean, you have to know you have low flow rates, or you get further down the drain, you get higher flow rates.
Yeah, so could this have something to do with flow rates? Yeah, the upper levels, we do have the lowest flow rates as well. Someone in the back?
I don't know if this has anything to do with what you're talking about, but a lawyer that had a lot to do with Rock Island told me some time ago that when they built the lines and stuff in Rock Island, that they put the sewer lines on top of the water lines, which was the wrong way to do it. Is that true?
I don't know. I do know from and the city of Rock Island has been a very good partner for us, and they've invited this study, invited the data. All right, so they've been a good partner for Augustana in allowing students to do this work. And I know that they have concern with aging infrastructure. I know they have a concern with, they believe it's very likely that some of these sewer pipes could be leaking into storm sewers. They don't think that's an unlikely scenario. As we've got aging infrastructure and limited money, of course, in Rock Island to replace things.
Kevin,
yeah, go ahead.
I was asking, the 1882 mine site is downstream from Singing Bird. You think that's having any impact on the John Deere site?
Yeah, that's an excellent question, and I kind of wish that we distributed the sites trying to get a picture of the whole watershed. I wish we had more sites and could look at things in a little finer detail in Black Hawk Park, because I would love to be able to see if that old mine site, is that a legacy source of some old buildings? It could be, but we just don't have the data to address that. Someone over here, I think, this time.
Years ago, I talked to someone who was a student in a science club at Rocky High, and they were very firm in the fact that nobody in Rock Island should be fertilizing their yards because they live between two rivers. Now, why is anybody in Rock Island using fertilizer? All you do is making more grass.
So why does anybody use fertilizer anyway? All you do is make more grass.
Yeah,
I wonder if you have included in the map the distribution of the rain gardens and the Rock Island Drainage Assistance Program sites. There are a couple of hundred of them, and I'm wondering if they have those on there to see what's happened around downstream from them.
Yeah, that's a great idea. So, Dr. Molina asked if we put the map on the map here, the rain gardens and the rain garden program in Rock Island, to try to see if they're having a beneficial effect. And the answer is we haven't, but we know theoretically that rain gardens are a great strategy, because one of the challenges that face urban streams, one of the most damaging things that faces urban streams is when they receive large amounts of storm water very quickly. That means their water levels tend to rise dramatically and they tend to fall dramatically. And when those water levels rise dramatically, animals get scoured out. Right? A lot of the beneficial invertebrates that usually live in streams can't live in this really flash flood sort of environment, and they just get scoured out. Well, rain gardens, rain barrels, bioswales, anything we do that helps retain the water and lets it percolate more slowly into the streams should reduce that intensity that those animals face, and it should be beneficial in the long term. So it wouldn't surprise me. I know Rock Island's been a really good steward of this. It wouldn't surprise me if that's having a beneficial effect.
Okay, just one last question.
One last question? All right, well.
When you talk about ways to treat some of these, and then you talk about some plants and trees that didn't quite get the name of those.
Yes, like I was talking about.
He was talking specifically if you wanted to try to do something at the John Deere roadside and the high containments.
So I was talking about were these plants called hyperaccumulator plants. There's like some studies show that some of these plants can take up a lot of these heavy metals and like chloride, things like that, that don't that most plants can't take up at the rate that these plants can take up. So they can like take up and store like a lot of these contaminants. And so if you plant on sites that you think might be contaminated, you could possibly remediate the site a little bit and get some of that chloride and heavy metals out of the stream. Well, for chloride, I did some research. It turns out like any tree in like the willow family can take up a lot of chloride. As far as lead, I can't remember off the top of my head. But if you just like Google like hyperaccumulator plant lists and you go like Wikipedia, it'll show you like certain plants that can take up some of these things. I think one was like a type of grass of some kind that is like found around here. I remember for arsenic, which obviously wasn't one that we showed, but there's this like mushroom that grows around here on our oak trees on slopes, very high, like higher moisture levels. It's like a bolete of some kind that can take up like a lot of arsenic. So that's what I was meaning by that. Yeah, of course.
Well, we want to thank, just remember, we now have dog poop bags in the States Park tonight. We don't expect to see any nitrogen or phosphorus coming from dogs in our park. Okay, so just as a reminder, and thank you guys for that, was great. They got little critters, micro critters. You want to see them. Hey, remember we've got free rat cards over here if you need them for